To prove this power rule, in this case, when n is a positive integer, that is to show that the derivative of x to the power n is equal to n times x to the power n minus 1. You must basically know several things like the meaning of factorial. For example, factorial 7 means 7 times 6 times 5 times 4 times 3 times 2 times 1, that is equal to 5040. Factorial 3 is equal to 3 times 2 times 1, which is equal to 6. So you can say in general factorial n is equal to n times n minus 1 times n minus 2 times and so on up to 1. Another definition you must know, NCR. It is given by this notation. So NCR is equal to factorial n divided by factorial r times factorial n minus r. Another thing you must know is the binomial expansion. If you take, for example, x plus h to the power 0 is 1. Anything to the power 0 is 1. X plus h to the power 1 is x plus h. If you multiply this by again another x plus h, you get this. Again by another x plus h, you get this. And you can see in all these expansions, the first term is going to be, if it is 0, is x to the power 0. 1, x to the power 1. 2, x to the power 2. 3, x to the power 3. 4, x to the power 4. Same thing with the last term. H to the power 0, h to the power 1, x to the power 2, 3, 4. And also we can notice that the coefficient of the first term also 1. Coefficient of the second term is equal to the n. See, 1, 1, 2, 2, 3, 3, 4, 4. So by keeping that in mind, if you go back to our general formula for x plus h to the power n, you can see n0 x to the power n times h to the power 0 and so on. So here the n0 is, as we said earlier, factorial n divided by factorial 0 times factorial n minus 0, which is equal to 1. And 1 is here factorial n divided by factorial 1 times factorial n minus 1. So factorial n go like that, factorial n minus 1 go like that. So you can see many terms cancels out and only n remains. So if you go back to our derivative of the function x to the power n, the derivative is given by this formula. I have explained this one very clearly in some other video. Now we have to substitute for fx. Fx is Sn, xn. What is x plus h? You have to replace your x by x plus h. So x plus h to the power n. So if you substitute here, and now you have to use this, you have to substitute this expression for your x plus h, and you get all this, and minus xn divided by h. See, these two cancels out. In the remaining terms, if you take h out, one of the h's out, you end up with this. So it will cancel with this h, because right now h is not 0. It is like a very small number, like 0.0001. And finally, you make the h approaches very, very small and approaches 0. So you can neglect all these terms. And therefore, the derivative of your function is equal to nx to the power n minus 1. So that proof was when n was an integer. In my next videos, I will have explained how it is going to be true when n is a negative integer and when n is a rational number like 3 divided by 4.